So in the yesterday's class, we were talking about polymorphism. We had discussed about different types of polymorphism, like compile time and runtime, method overloading and operator overloading, and then method overriding. All that we had discussed in yesterday's session. So today we'll jump to the another very important topic of OOP, object-oriented feature or principle, which is nothing but abstraction. So what is an abstraction? And how do we implement abstraction in Python? That we see in today's session. It's a very simple thing. With the kind of knowledge we have by now, we can easily implement this abstraction or encapsulation, whatever it is. And today we try to complete all this. So which almost closes the principles of OOP. So this will finally conclude the OOP concepts, because with this we can cover object, class, abstraction, encapsulation, inheritance, polymorphism. So these are all the core principles of OOP, and we covered each and everything there with in-depth analysis of each and everything. So what is an abstraction here? Simple. Generally, if we talk abstraction, so it is something like this. So first thing, understanding abstraction. In simple definition, abstraction is nothing but exposing something without actually showing it to the outside world. Abstraction is a principle, right, which exposes only the signature of a method, but not the actual implementation. Got it, right? So it's simple. In a simple definition, abstraction is a process of exposing essential things. Whatever that is needed, it will just show only that. Hiding background details. Hiding background details. So this is what abstraction is. You got it right. So this is one of the core principle of OOP. Simply speaking, what it does is it just exposes essential things. Whatever that is needed, it just show you, and it hides the background details. So again, it's not data hiding. If you ask me, it's not data hiding. Here we talk about abstraction with method signatures. We'll talk about it just in few minutes. But this is abstraction. Providing essential information, hiding background details. How do we do that? That we are going to see in today's session. Definitely, today's session give you a very detailed idea about abstraction, even encapsulation. We implement abstraction in two ways by using one is abstract method and abstract class. Suppose if you ask me what is an abstract method, simple, it's very simple. Let me take that example one by one. So abstraction or test, we can say anything. Abstraction test. So generally we implement this abstraction with the abstract method and abstract class. So these are very important things. So what is an abstract method? Simple. We know methods, right? So when we talk about methods, any method, generally, let me just put that here. So let me add a point here. We can break down methods into different types. We know that by now we have learned different types of methods. Normal methods or instance methods, static methods, class methods, you know all that. Again, all this falls into two categories. One is generally we can break down methods into concrete methods. So what is that concrete method? Second one is abstract methods. So what is the difference? So concrete methods means methods, any method, whatever method it might be, A method with body or implementation. So simply speaking, a method with the, what is that friends? A body or implementation. So this is what we call concrete methods. For example, let me just show you because these are all very important things to know. You can say DF. So you can take a class because this is more connected with OOP. I'm showing this in classes. So DEF, you can say you can just take some M1 and then you can add something in under this method. So hello, just saying something here. So this is a concrete method. This is a concrete method because it has a proper implementation inside this. Okay, what is an abstract method? So, and how do you define that in Python? A method without body, simply speaking, without body is abstract method. But like in Java or C Sharp, we cannot we cannot just declare method signatures or no implementation, of course. Right. So if it is Java or C Sharp, what they do is they create a concept of abstract class, after abstract methods and classes or interfaces. And they just use method signatures. They don't have any body at all inside that. But Python cannot just do that. We can just simulate that situation. So how do you define abstract method? Simply, you can just say something like this is an abstract method. See, you just need to say pass under that. When you just add pass, it means that we don't have implementation. And to make it a proper abstract, on top of this, you should do one thing. If you want to make it abstract at the rate, you can just say alias. Okay, you can see this. You can use this abstract method. This is the annotation you should import. You can see this right there. But to use abstract method, abstract class, we have to use something called this module. What is that module? ABC module. Got it right, friends? So this is the idea. So now this is a proper abstract method. You can see if you see this method and this method, there is some difference here. This is a method without any implementation. If you just put pass means something without implementation. Right. Whenever you see pass means you have to assume such methods are abstract methods, means with no implementation. And here you see this method is having something inside that it is a concrete method, a method with some implementation. So this is the difference you have to see, you should understand. And if you when should we define abstract class? So this is idea about abstract method. If you should define abstract method in a class, then that class should be declared as abstract classes, right? So then if you want to make this class as abstract, then this has to be inherited from a base class, abstract base class. ABC means abstract base class. This should be inherited from there. Okay. So that is what you should do. We'll try import it. We have to import it. I'll show you all that. But I'm giving you all the details first. Later on, we'll go to the example. So this is the idea, friends. If you want to create an abstract class, then we should inherit it from a built-in class which is called as abstract ABC class. You got it, right? So what is an abstract method? A method without body. And when should we declare a class as abstract? If we should declare abstract method in a class, such class has to be declared as abstract class. Okay, and if you want to make it a proper abstract class, then it has to be inherited from a super class called as, or a built-in class called as ABC, which means abstract base class. We'll make it very clear. Okay, but these are the important points you have to understand. Now, if you see this, you can understand this now. What is this here now? So this is How we implement achieve abstraction with abstract class and abstract method. First thing you should understand about abstract method, a method that is declared but contains no implementation. By now, this should be very clear. We should be very clear. And where should we override this abstract method? Subclasses must override. We know inheritance and we know overriding as well from yesterday's session and last few classes. That is actually the basic base for all this. Okay. So we implement this abstract method in a subclass. What is abstract class? A class that cannot be instantiated directly and serve as blueprint for other classes. We'll talk about it. So generally, abstract class can have abstract methods. That is one thing. Second thing, we cannot instantiate abstract methods directly. Of course, indirectly you can do that. So that is the idea. Now, how to implement abstraction? We should use these two. One is ABC. Just now we discussed, right? We should import ABC and abstract method from this module ABC module. What is that? Step one, import ABC and abstract method decorators from ABC module. Okay. And second thing, what is that we should do? You create an abstract class by inheriting ABC class, abstract base class. And using this abstract method decorator, we create abstract methods. And we implement this abstract methods from abstract class in a subclass. So these are the steps we should follow. I will show you all this with examples. You got it right, friends. Let us just see this with examples. So now what you do here is, so I think these points are clear, right? So you have to just add one more thing, ABC comma, that's all. First, you should import this. One is ABC class, another one is abstract method from ABC module. If you should implement abstraction. Abstract method is used to create abstract method. This is for using declaring annotation abstract method or decorator abstract method. And this is for inheriting or creating abstract base class by inheriting that class from ABC. Okay, let us start this example now. So we'll take a small example. Let's not first let's understand that. Suppose you take an example. Okay, so I'll start from one more time from scratch. I want to implement abstraction or I want to add abstract method in a class. Then what do I do? So first I take a class, something test. Let's take test itself. Now this is just a concrete class. This is not abstract class. We didn't inherit ABC into this class. If you don't inherit ABC, that abstract base class, then this class acts as a concrete class, a class with proper implementation. Now what I do, I take a method M1, okay, and under that I just put pass. Now what I do, I make this as a abstract method now. How to define abstract method, you know very well. We have to use decorator abstract method on top of a method. And this method don't have any implementation. Just if you put pass means it is abstract method, a method without implementation. Okay. On top of that, make sure you put this method. Now inside class test, we have abstract methods. Got it right. But this is not a proper abstract class. Suppose now you see, I do one thing, something like test equal to test. Okay, now print. Okay, I'm just printing it. I'm not doing anything. Just print test. Right click, run this. Now you are able to instantiate this test class, right? Generally, if it is abstract class, we can't instantiate or we should not instantiate abstract classes. We should not be able to instantiate abstract classes. Point one, what is that? This is how we define abstract methods without implementation. Just under a method, if you put pass, that means you are making this method as abstract without implementation. Right? And this, when you add decorator, this makes technically an abstract method. And apart from that, if you should declare a method as abstract in a class, that class should be abstract class. Right? Then how do you make it abstract class? Inherit this from where? From ABC, abstract base class, to a subclass. Then this test acts as abstract class. Now this is properly defined. The class is abstract and we have abstract method in abstract class. Generally, abstract classes cannot be instantiated. Now right click, run this. Let's see. You can see error now. What is the error? It's clearly saying type error. Can't instantiate abstract class test with abstract method M1. So this is how it has to be. And this is perfectly working as expected. Once you declare a class as abstract, so point is abstract class cannot be instantiated. So that is important point. That is number one. Another point. What is that? We cannot important point here. Instantiate. What do you mean by instantiate? Create object. Instantiate abstract class. That is one thing. What is there inside abstract class? Abstract class generally have abstract methods. An abstract class will have what? Abstract methods defined inside that. And there is another question again. Can we have non-abstract methods or concrete methods in abstract class? That is another question. Okay. Yes. In an abstract class, you can have both. Let me just show you that as well. D of some F1. I'm just making a simple method and just print. So hello. But even though you have concrete method, I think you can't do anything directly. If you want to call this, then that is possible only through subclass, right? So suppose what is that we should do? Once you define a proper abstract class with abstract methods, method definitions, right? What do? You need a subclass. Suppose you take here class, something like test2, okay? And that is inherited from test. Now in this, overriding, right? Here we have to override this M1 method. So how do you override? Define M1. And then what is that you should do? You should say print, okay, I, something. So this is how we have to implement what we should implement this abstraction. Now, what is that we are doing here at top level? We are creating abstract class and defining abstract method or methods inside that. Of course, in an abstract class, we can also have concrete methods. Now, what is that we do? If we should implement abstract method of abstract class, okay, that we have to override such methods in the immediate subclass. So now I inherited this test, which is the abstract class to test2, and I override the abstract method M1 in the subclass with the implementation, with a different implementation. See here. Now finally what I can do? Now I can create object for what? For test2. So test equal to something like test2. Okay, and then now I can say test dot M1. Similarly, I can say test dot F1 also. I can call superclass members on subclass object. This is possible. But I cannot instantiate test, but I can instantiate test2 because this is directly an abstract class. So we can't instantiate this. So if you run this now, see this, right? Unindented. There is a slight indentation issue. Okay, let me just move this. Yeah, see, now we should be fine. Let's run this now. See, hi and hello. So we are getting output, right? This is the simple idea of abstraction. Finally, you are clear, right? What is abstraction? What is abstract method? How to implement it? What is abstract class? Where should we define abstract methods? And how to make a
One
class
doubt,
as
sir.
well. Yes, yes, please. Yes,
What
ma'am.
is the use case of this abstract class? In which circumstances we tend to use this abstract class?
Generally, while this is used in the project design, ma'am. So suppose you are building a new project, and if you want to summarize or if you want to create a design, let me just talk about this. So if you are using abstraction, so this is used at design level. If you want to know why this abstraction, why all this, when we create all this means when you are creating, right, after requirements gathering, you have all this life cycle, this thing, right? So software life cycle. Before you go to coding, you do design. In the design, you have to make sure that which classes should be having concrete methods, which should have this abstract methods. Because simple. Suppose you take the example of some bank itself. Suppose in that bank there is a method pay, right? Bank class name bank is generic one and pay is generic. Now I try to inherit it with two other classes. Like I have a class like credit card, right? This credit card can have a different approach of payment. Similarly, you can take a debit card. So this has a different approach of payment. Similarly, right, you can take other banks as well. From bank, you try to inherit HDFC Bank. Okay, this have a different payment approach. So when you have a super class and subclasses like this, and the payment implementation changes from one class to another class. In the design, what you do, you don't directly implement payment in the bank class itself. You make this pay or payment method as abstract. And you define all such methods, not just pay. There will be so many methods which can be overridden in the subclasses. All such methods, you define them as abstract in the superclass so that in future developer can override that method in the subclasses. And this is how we implement abstraction. And this is more or less this is a principle that is mostly used at design level in creating that design documents, everything, so that you create a kind of hierarchy here that this classes should be abstract classes and these methods should be abstract methods, so that and they have to be implemented somewhere in down the hierarchy, something like that. So what is the advantages with abstraction? Definitely. So one thing we achieve here is we don't provide the actually we don't expose any implementation. So if you ask me about abstraction, abstraction is protecting the implementation, simply speaking. So here we have whatever the that logic implementation or method implementation, you don't need to expose outside. You just need to expose these signatures. So that is what we achieve with abstraction. See, as per definition, providing essential information, hiding background details. So in this case, the advantage with abstraction is we protect that implementation and we don't expose that outside. And also apart from that, say as a point, as a definition, this is fine. But if you ask me, the exact purpose in development is it acts more, it is more useful to define some kind of generally, right, what kind of method should be concrete, what should be abstract, and if in case if it has a different implementation at each subclass level, then better avoid implementing it in the subclass. Such methods you make it as abstract so that in future you allow developers to choose their implementation. So in all these kind of scenarios, it helps to do a proper design. So that is the simple idea, ma'am. But as per regular definition, in a way, we are actually protecting it without exposing that implementation details. That is what the purpose of abstraction as per definition. What is that? We don't expose that implementation details of a method. We just expose method signatures in a way. But more than all that, because if a developer is there, if we go and see into that abstract classes, he knows what is abstract, what is non-abstract, all that. Got it right, ma'am? This is the simple
Yeah,
analysis.
yes, sir.
Yeah. So that is the
So
idea.
basically, we are designing a template which can be used for
Correct,
multiple
correct,
projects.
correct, ma'am. So that is the actual
Got it.
purpose. But people talk about definition, but I don't feel more than definition, whatever you mentioned, that template thing is the crucial part here, ma'am, or the core part. You got it right? So that is the idea.
Understood. Understood.
Yeah. So, okay, finally, let's take a quick example and implement it. So let us take a proper example now. So for what I did is to make clear the concept, I just used a simple example. Another example, same thing. You know this animal thing we know from yesterday's discussion or day before yesterday as well. You have a sound method and that sound changes from subclass to subclass. Most of you know that. And if you implement sound here, that doesn't make sense. Making sound here abstract is more meaningful. So that each subclass will implement sound according to their requirement. You got it right, friends. So that is where we should choose making these methods as abstract. And once you have abstract method in a class, then that class has to be declared abstract. Suppose you see here, we do one thing. Let us not define any abstract method. Sorry, let us define abstract method. But if you don't, yeah, I think this principle don't work here. If it is what shall I say? If it is other languages like Java or C sharp, it should work. Okay, let me test it still. Do one thing. Let me test it. This is what I'm making it very clear. I don't want to confuse you. Don't inherit ABC. So if you don't inherit abstract base class, what class is this? We can assume this class as a concrete class. And inside concrete class, you have abstract method. Now what I do is I'm just directly creating object for concrete class. But generally inside concrete classes, we don't declare abstract methods. So you say test dot, sorry, test dot sum f1. Okay, test dot sum m1. Let's call this right. So let us see and remove these things here. We don't need this. Now this is the example. What is that example? So generally we declare abstract methods in abstract classes. And to declare abstract method, we use decorator abstract method. To declare abstract class, that class has to be inherited from ABC, built-in class ABC, which is abstract base class. And generally abstract classes cannot be instantiated. That is, these are the important points you should remember. Now, what is that I am doing? I am doing another testing. Inside concrete class, I put abstract method, which is not actually the recommended approach. But I did that just out of curiosity. This is still working. But if it is Java or C sharp or something, it won't allow because they immediately say concrete class unimplemented method abstract method. But somehow Python is allowing it. But this is not a even though it is allowing, it is not a proper template to define like this. Right? We have to create a proper template when you are creating abstract method and classes. And this is not the right recommended approach. Got it. But anyhow, we tested. Somehow it is working. And if you call M1 don't have anything, so we are not seeing any output. That is fine, but not seeing any error. But if you do the same in other languages like Java or C Sharp, it throws error. I'm very sure because I worked on Java at least for right 4 or 5 years. And I taught Java at least for 10 to 15 years. So with that experience, I am saying. So this is the idea. So I'm just, but anyhow, so in programming, you have to abide by the principles. Even though certain things work in programming, you should not do that. That is how you have to make sure you are following that approach. You got it right, friends. Just I just did a cross check, and with that check is passing, which generally we don't need this. Okay, we don't need to follow this approach, not a recommended one. That is the idea, friends. So next after that, so this is about what is that abstract scenario. Let me share this first example with you. I didn't share, I believe, first thing. Yeah, let me share this with you first. Right click, run this. So let me first, you can take this example. Next after that, once this is done, the next example is, this is clear, right, for all of you friends. Next one, we'll take this example. What is that? Abstract base class. So let's take animal. So you can take this example. Or otherwise, I can directly create it, not a problem. So another example. So new class. So abstract. Okay. Abstract ABS test2. Let's take this. You can take a class animal. Now inside this, define an abstract method, DEF. What is our abstract method? Sound. Okay. And just declare pass. So this is how you define abstract methods in Python. If it is Java or C Sharp, you don't put pass, just a signature. That's all. That acts as an abstract. But before that, in those languages, there is a keyword called abstract. You have to apply that. But here instead of keyword, what do you do? On top of method, you apply what is it? Abstract ABS abstract method decorator. When you add decorator on top of some method, that clearly says this method here is abstract method. No body, no implementation. When you look at that, that is very clear. Now we have abstract method in a class, but is this class is abstract? No. Then how can I make this class as abstract? By using built-in class ABC, abstract base class. Okay, so how do I make animal as abstract? So far, this is not abstract. So if I should make animal abstract, inherit it from ABC. Now animal becomes abstract, and inside abstract, I have abstract method. Inside abstract class, you can have both abstract methods. If you want, you can add one concrete method, something like sleep or something, which is shown in the example print. Okay. So I am sleeping or something. I am adding just something like that. Let it be like that. Now you take another subclass, class dog. Okay. And you inherit animal. Now what do you do? Generally, as per rule or as per recommended approach, when you inherit abstract class to a subclass, we should implement these abstract methods in the subclass. So what abstract method we have sound here? That sound, whatever is not implemented, we should override. You know the override topic, right? We should override this in subclass. Overriding means defining method of superclass in subclass with a different implementation. That's what we call overriding. Implementation changes. So what do you do here? So here you just say something like oof, oof, or rough, rough. You think whatever is good for you, you can add that here. Right? That is the simple thing. Next, you can take one more class, cat, and we can override the same sound method. Again, inherit animal to cat, override the abstract method, provide some implementation. If cat has a different sound, right, it meows. So you just say meow or something. So that is cat's thing. Okay. So this is how you have to create this abstract classes and its subclasses. And we should implement this abstract method of abstract class in subclass. We should override with a different implementation. That clear, if you look at this example, it is so simple to understand. Here, this method doesn't have any implementation. Now we are changing that in the subclass. So this is the idea, right? Abstract methods must be overridden in the subclasses. Got it, right? So finally, what we should do, create object for dog. And maybe you can directly call that dog dot sound. Similarly, create object for cat. Okay. And what you can do on cat, you can call sound method. We are done. So right click and run this now. So finally, this is how we implement this concept of abstract classes. Got it right, friends? So that is the simple idea about abstract method, abstract class. Okay. In overriding abstract methods, importance of ABC module, importance of ABC class and abstract method decorator. Okay. So I'm just sharing this with you, friends. Let me share this with you. Hope this is clear for all of you about the concept. This is abstraction, friends. Overall, what is abstraction is simply speaking, in this super class, you are not exposing the implementation, right? It's nothing but hiding implementation and just exposing method signatures. Method signature means that method name plus parameter list is nothing but method signature. Okay, that is the idea here. Okay, friends, let's do one thing next after that. This is overall idea about abstraction. So this example covers everything. This is enough for us, friends. So finally, we are good with the concept of abstraction. Okay, now let's move to the next topic. We are done with all this. Now they are moving to a topic called so that topic is encapsulation. So the next topic we are going to talk in today's session. So what is the topic? Encapsulation. So yeah, let's start talk about that. What is encapsulation? So we have covered abstraction just now. Now let's talk about encapsulation. What is an encapsulation? Simple. Same like abstraction. Abstraction provides method, implementation or implementation details. That's what abstraction does. But encapsulation protects data. That is difference between abstraction and encapsulation. If someone asks you a question, so what abstraction does is abstraction protects implementation, method implementation. Much to be more clear, method implementation details. Okay, implementation details. But an encapsulation is a whole different kind of principle where encapsulation protects data. Data protection or data privacy is implemented with encapsulation, right? So what is encapsulation here? It is a core principle where we don't expose data of an object outside to the outside world. Outside in sense to outside classes, outside objects. And that is encapsulation, simply speaking. So this is also one of the core principle in OOP, not Python, in OOP itself. Right. And here, what is that it is happening? I already just made it simple. What is encapsulation? It's in a one word, it is data protection, friends. How do you protect all that? We see in the next few minutes, we are going to get that idea. Okay, it is the concept of what bundling data or binding data and methods together. In encapsulation, what do we do is we try to bind or combine or bundle the data, the variables which we are using, and the methods which we are operating on that data. We combine them into a single unit. That's what encapsulation is. Got it, right? And how do we do that? We prove all that with examples. And the advantage with encapsulation is what is that we can add data restriction. We can restrict access of data to the outside world directly. Got it, right? Some you can see here. What is the advantage with encapsulation is restricting access to some of the object components. You know already from the discussion we have in the past 1 week or more than that, object internally holds data. They are some kind of data packets which has some values inside that. And those values can be both public data and protected or private data. So if you want to restrict access to that private data from that objects, then we implement this encapsulation, simply speaking, right? So how do we achieve encapsulation? Simple. We achieve encapsulation mostly through private access. Protected is okay, but private is the most powerful tool for implementing encapsulation. And we achieve this encapsulation by either by using private access or protected access. But protected is much more higher this thing to avoid access. Right? So that is the idea here, friends. Okay. So finally, this is the idea of encapsulation, right? And now let us see that how do we implement all this different access in Python. We implement this all this different access. What are those access we have in Python? So far, we didn't discuss this topic. So this is something really needed for us. Okay, so we have public, we have private, and we have protected. These are three different access what we have in Python: public, protected, and private, or private, protected, and public. Anything should be fine. So finally, what is the advantage with the encapsulation is right? It hides the internal state of object. Internal state means you can hide your data with encapsulation. In a way, in one word, we can say we can do data hiding with encapsulation. And to achieve that, either we use private or protected. Public is fine. Whatever we use directly. By default, all members in Python, that variables, those methods, those classes are what, friends? They are public members. Right? If you don't add anything, or they are public. Now, second thing, how to define protected member? Simple. We define protected member just by using just an underscore, single underscore, one underscore. We will see all that with examples. Right? Attributes and methods that are meant to be used within class and its subclasses. So when should we declare these members as protected? Protected members means they are members which can be used in the same class or by its subclasses, but not by other classes. So such methods are protected members. Same like property, simple example. Suppose I earn some property, that property can be used by me or by my children, not by others. Same thing. If a class has variables and methods, those members can be, and if they are protected, and those members can be used by either by that class or by its subclasses. That is the idea of protected. Got it right, friends? Huh? And generally, you declare protected members with single underscore. We will see that with example so that that gives you a very detailed idea. Second thing, private. Private means, so these members are members where we can't access them anywhere outside, even to subclasses. That is private, right? Attribute and methods that should not be accessible from outside a class. These are members which are visible only within a class where we declare, and they are not visible to any other outside class, even to subclasses. And such members are called private members. And these private members are declared in Python using double underscore. You can see this. What is it? Double underscore. We'll see a small example that will overall give you a clear idea about that all different access modifiers. And finally, we will also see how we approach, I mean, how we implement that encapsulation. Here, we are also covering multiple things in this discussion. We are also having a clear idea about access in Python. But like in other languages, we don't have keywords here. Access modifiers are not keywords in Python. If it is C++, if it is Java, if it is C sharp, they use Java and C sharp use public, private, protected keywords. Of course, there is one more scope default there. Without, if you don't use any keyword, it is a default scope. But in Python, we don't have those many. We just have just three. And that too, these are not keywords here. If you don't use any underscore with variable or method, they are all by default public members. And by default, the access is public in Python. So this is the idea, friends. Let's get into the implementation. We'll take an example and we try to apply that. And we get into the more discussion about it. So now let us create a small example. I'll just make it simple first because that is how I want to go. So more than confusing us, so what do we do? Let's make it simple. Let's say access test here. Now you know the basics of access modifiers, how to define public. Suppose you take class, okay, some person, or you can take anything, friends, or employee, whatever you think is best fit for you. Okay, and then you take a method, some init. In this init method, you say self dot name equal to, you can, if you want, you can define some, what is it, some parameters. Okay, and this name is a public variable and you can assign that name to name. So we are also doing initialization of this instance variables, name, age, salary. Let's take these three. So this is actually a public member. Okay. Next after that. So why it's public? We don't have any access here, public. Okay. We don't have any underscore or double underscore here. If you don't have any underscore, sorry, I mentioned access, I believe. Any underscore, then by default the access is public. Next one, self dot, okay, underscore age. This is a protected variable. If you have single underscore, then it is what, friends? It is a protected member. Okay, and this member is accessible within same class and by subclasses. And next one, self dot underscore salary. Okay, and you set salary to salary, and this is private member. This is a private member. See here. So we have defined three different variables with three different access. Now we are going to test them in the main. We are going to test in the driver code. So what is that we have? By this should give you a clear idea. right? What is that? By default, if you don't use any underscore with any variable or method, such methods are, what is that? They are actually, what methods are these, friends? Public members. If you use single underscore protected, double underscore private. Okay, fine. That is enough. You can just leave it like that. What do you do right now? You can say some person equal to person, create object. And you know, right? So again, you might get a question. We have underscore with this both left and right. So even are these private members? These are not private. These are magic methods or dunder methods, which are used exclusively on certain special cases. That's all. Right. We can call this init from outside. See, when I instantiate object, init is automatically called. Right. It is not private thing here. This is the proper way of defining protected or private. Now, when I call init, you can see here. What is that? When I call this, when I create object, constructor is automatically called. We know this from our previous discussions. Then this initialization happens. Now we are doing a quick testing. You know, right? When you do this, object is created and then that object is loaded with all these three variables. Now I'm doing a quick testing from outside, not from inside. What is that? I am trying to call person.name. Can I access name from outside? Is it possible? This is first thing. So accessing name, right? From where I am accessing from outside. Is this possible or not? That is question one. Next again, I am trying to access protected member outside and also private member outside. And there are few recommendations we need here. We'll talk about all that. Person dot underscore age. This is okay. Again, person dot underscore. You are not even seeing salary. See there on that object or reference. When I say underscore salary, you are not even seeing that. That itself shows private members are not strictly accessed outside. Okay, but it's okay, fine. There is a way to access them. We'll talk about all that. You need to know them. Now you created object. We are testing. This is just a test to understand the scope of each member. If it is public, see, there is nothing much discussion on public because public members are accessible anywhere directly without any issues. So person.name can be accessed without any issue or a problem. Second thing, I am calling this protected member. You know, right, as per this thing, protected members should be accessible within that class or by subclasses, not outside, from outside. Now we are calling from main scope or from the driver scope. Even this should not work like that. But still this can be accessed, but not recommended. What is it? Not recommended. So here there is no pure control on protected data in Python. On protected data, we don't have a pure control. But we should, because it is coming or because we are able to access protected outside directly, still we should not use such approaches. That is not recommended at all. Means we are breaking that encapsulation principle. Even though this protected might be accessed outside, right? Still recommended is, so what Python people are saying this is don't access protected directly like this. If you do that, you are breaking that encapsulation principle. That's what they say. Right. And finally, of course, this don't directly access. We have accessing issue with salary because this is a private. We can't access it directly now. Now, if you run this, see the output now. So what is happening here? In it, of course, I should pass three values. That is what missing here. First one, name, something like I say Peter. Okay, let me pass values. Peter, Second one, age, you can pass some 40, and then salary, you can put something like some 20,000 or something, or 2,000, anything should be fine. Now you run this. Of course, this is a parameterized constructor, right? By now we know very well if it is methods are parameterized, we should call them by passing values. If it is constructor, we should pass values to constructor through object. This is clearly discussed. Now I am passing all these three through constructor call, right? Now let us run this. Now you can see Peter is there, age is there, but what is missing? Salary is missing. See, attribute error, person object has no attribute salary. Suppose you put a debugger here. Now you understand the secret here. Now see the secret. Which are inside object, which are not inside object. This debugging gives you an idea. See, observe this window, variable window. So this person class is loaded into memory. This is fine, right? So for now there is nothing. So you go to the next thing. You don't need to go into constructor and check all that. Just go to the next step over. Now when you say step over, person object is created. Inside that person, what is that you have here? You can only see what variable here. You can only see name variable. See, in this person object, how many variables you are seeing? We have three variables inside the class, inside constructor. But outside directly, you can see only one variable name. Not even age is present inside this object. Right, friends? You are getting this? See, this should be very clear for you. Of course, now you do one thing. Call name is accessed. And age is, you are not seeing age inside object. That itself is a proof that protected is not directly accessible outside. Got it, right? We are not seeing that here. Right. So next one again what, but still, if you access protected member directly, it might come. Again, I clearly made this point. I am not saying this. This is actually the what Python people are saying. Don't call protected like this, even though it might be accessible. Got it, right? If you do this, you are breaking that encapsulation principle. So don't do that is what Python people says. And finally, next after that, right, go to salary. Salary anyhow is not there. You get an error. Why you get error? Because you are not even seeing that inside that person object. Without that, you can call. We cannot call. I hope this should give you a clear idea because you are able to see what is there in each of what is there inside object, which can be called, which cannot be called. This example should clearly establish a basis for that. Got it, right? But suppose you just remove this underscore, remove this underscore. Now you debug this, just a quick this thing to show you. Now debug it, right? Go to the next one. Now expand this person. This time you can see all three variables just to show you difference. You can see name, you can see age, you can see salary. But in the previous debug scenario, you are not able to see that age and salary because age is protected and salary is private. So that those private members are not accessed directly outside. Right, suppose again if you change this to underscore and if you change this to double underscore, this is a very clear proof that protected members and private members are not meant to be accessed directly outside. We have an approach, we'll talk about that in tomorrow's session. So then in case, how do we get that protected members or private members outside? What is the approach? Then we have to deploy something called as setters and getters. With that approach, we try to modify data of object indirectly, not directly. So that is the mechanism we apply or we employ inside a class. You got it right, friends? So this example should give you a broad view of a clear difference between access modifiers. And this debugging should definitely give you a clear cut proof of how this public is protected, is private, is all that. Got it right, friends? So here, this is not accessible or this throws error here. Okay. I'm just adding and sharing this with you. Okay. Not accessible. You can simply just adding. Let me share this code with you. Not accessible. So this is accessible, not recommended approach. Why? We have a clear definition, clear discussion on that as well. Protected member may be accessible, not recommended approach. Okay, I'm sharing this code base with you just for testing. Okay, and I'm removing all this. Okay, maybe we can just run it directly. Okay, copy this, just sharing this with you. Hope this was clear for all of you friends. Got it right? Tomorrow we will mostly we are done with this OOP principles. Okay, so we'll jump to the next topic. Probably we'll take up exception handling in tomorrow's session. Probably after closing this, there are few things we need to talk. What is that? The setters and getters, all that. Again, those are all very important things. It's not like if you want, we can skip it. But you know, as I'm into this thing, right? Setters, getters, all that also something really useful for you. And how do we modify private data from outside environment? So how setters and getters are really useful, right? All that we see in tomorrow's session. Okay, we'll stop this for now. And then the next topic probably is we'll jump to exception handling, right? So any questions? Any questions, friends?